So for the second part of translations, we're going to be talking about a vector. And another way to describe a translation is by using a vector. A vector is a quantity that both has direction and magnitude. So we're going to fill these in right now. A vector is a quantity that both has direction and magnitude or size. And it is represented by an arrow drawn between 2 points. The diagram shown is a vector. The initial point or starting point of the vector is P. So it's kind of like array, and you have to be really specific about where your starting point is and where your ending point is. So they don't work in both ways. You have to make sure you're very specific of where your starting point is and where your ending point is. The ending point, or it's another name for the terminal point, is Q in this diagram. So you can see we have the starting point or initial point is P, and then the arrow is showing you that it keeps going, but that is also known as the terminal point. The vector name PQ is read as vector PQ. Other ways that we can describe this is, if you continue, the horizontal component of vector PQ. Well, if we look back at this diagram, horizontal means going from left to right. So if we look at this diagram, if we're looking at how many units left or right that this has gone, it has gone 5 units. So the horizontal component of this diagram would be 5 units. So we would just write 5 in the space. The vertical component, and vertical means going up and down, a vector PQ would be 3. And going back to the picture, you can see that it's going 3 units up. So I almost like to think about this as almost rise over run again, because we're going 5 units to the right and 3 units up. So horizontal component is 5, vertical component is 3. And then if you were asked to write something in component form, of a vector combines both the horizontal and vertical components, then we would say the component form of vector PQ, you always put your x value first, or your horizontal component first, then your vertical component. If we were talking about our specific vector, we would write 5, 3. Notice the notation. All right, so let's go ahead and start practicing this. We're going to do one together, and then I'm going to let you try another one out on your own. All right, so if we take a look at this specific vector, our initial point is at A. The terminal point, where the arrow is at B. So we would name this vector A, B, and it has to be in that specific order, with the initial point coming first, followed by the terminal point. If we're talking about component form, we need to figure out what's the horizontal to the vertical distance. Okay, so if I'm comparing that, going from A to B, I'm going to count over horizontally from point A to where I would line up to point B. So that's going from 1 to 4. So that means the horizontal component would be 3. And then to go up vertically, since I'm at 1 and I'm rising up to where I'm at B, that would be 2 more places to get from 1 to 3. So component form would be 3, 2. If I were asked to write this in component form, that would be almost like asking you, how many places did I slide to the right and up to get from point A to point B? So that's how this kind of all relates back to translations. So I would be going 3 units to the right and 2 units up. So that's how I'd be writing this in coordinate form. All right, how about you try this one? So again, I want you to try out writing down the initial point, the terminal point, the vector name, the component form, writing your horizontal to your vertical form or component, and then writing down the coordinate form. So pause your video and see if you can get these correct. All right, so if you guys are taking a look to see if you guys got these correct, your initial point would be at D, your terminal point would be at E, because this is where I see this arrow at. The vector would be properly named as vector DE. In talking about component form, the horizontal component would be 2 units because I'm going from 2 to 4. The vertical component would be dropping from 4, starting at the initial point, going down to the terminal point from 4 to 1. So that would be dropping 3 units. So that's why I have a negative 3 there. And then converting that to coordinate form. So that would be going 2 units to the right and then dropping 3 units down. Okay, so again, let's try out these ones. So on this one here, this vector would be called vector CD. And in terms of the component form, I would be going over 1, 2, 3, 4 places to the right for the horizontal component, and 1, 2, 3 units up for the vertical component. Okay, for vector PQ, because again, we're starting at the initial point and going to the terminal point. Look at where the arrow is. I would be going 1, 2, 3 units left. So that would start negative 3 and then down 1, 2, 3, 4 units. So the vertical component would be negative 4. Okay, now what we're going to do is we're going to use the component form to help us to translate a triangle. So triangle DEF, we're going to plot that right now. So right now let's pause our video and take a moment to plot triangle DEF using these coordinates. Okay, so I've plotted triangle DEF right now. This is the original, okay, the pre-image. If I take a look at my vector, the vertical component and the horizontal component right here are 3, 6. So the horizontal component is 3 units, which means that I would be sliding this 3 units to the right. Okay, and then, hang on one second. Let me delete this. Okay, so that would mean that this would be 3 units to the right, and this would be 6 units up. So again, we would be adding 3 units to all of our x values, and we would be adding 6 units to all of our y values. Okay, so right now we can figure out what d prime would be, what e prime would be, and what f prime would be. Okay, so if I'm trying to figure out what d prime would be, if I added 3 to all those values, let's see, that would turn into 1. And if I added 6 to that, a y value would be at 3. For e prime, this would be at 1. And then adding 6, that would be at 5. And then for f prime, adding 3 and adding 6. So 3 and 3 give you 6, and negative 1 plus 6 would give you 5. Okay, so again, we're going to plot these values to see where d prime, e prime, and f prime All right, guys, so when you take a look at your translated triangle using this component form, you can see that D prime, E prime, and F prime would look like that it was translated or was sliding 3 units to the right and 6 units up. For the last part of today's lesson, I want you to write the coordinates of the vertices of the image produced by translating triangle ABC using the vector. So again, I'm not asking you to graph this. All I want you to do right now is take a look at our pre-image, which has the coordinates of -2, 5 for A, 3, 0 for B, and -1, 3 for C. And I want you to take a look at the horizontal component and vertical component for 2, 3, and 4 and figure out, using that horizontal and vertical component of each one of these vectors, what would be A prime, B prime, and C prime for each one of these problems. So take some time right now and see if you can figure out using those horizontal and vertical components for each one of those. All right, let's see if you got those correct. So if you take a look at question number 2, if it has a horizontal component of -4, so you'd be sliding these to the left 4 units, and a vertical component of 8, they'd be going up 8 units. We'd have answers of A prime at -6, 13, B prime of -1, 8, and C prime of -3, 5. For number 3, we would have no units left or right, but be going 6 units down. So A prime would be -2, -1. B prime would be 3, -6, and C prime would be 1, -9. And then for number 4, the horizontal component would be 7, so we'd be sliding this 7 units to the right and no units up or down. So A prime would be 5, 5, B prime would be 10, 0, and C prime would be 8, -3. So again, in today's lesson, remember, we're still talking about translations. Vertical and horizontal components of part of vectors are just a different way of writing translations.